In the next programming screencast, we are going to implement K-shell decomposition. So I hope you remember what was the algorithm for K-shell decomposition. First of all, we take bucket 1, and then after taking bucket 1, we start removing the nodes having degree 1. So we see that this node over here, these nodes have degree 1, this node has degree 2. So these 3 nodes have degree 1. So what we are going to do, we are going to remove these 3 nodes and put them in bucket 1. So let me number these nodes also. So what I'm going to do is, let me number these nodes first. Okay, so we are going to take bucket 1, and in bucket 1 we'll recursively put the nodes who have degree 1. So first of all, nodes 14, 12 and 11 go to bucket 1 because they have degree 1, and then we delete these nodes from this network. So we cut node 14, 12 and 11 from this network, and we put them. And next again we see that there are degree 1 in this network, and then we recursively remove these nodes also from the network and put them in bucket 1. Similarly, we determine bucket 2 and bucket 3 in this network. So bucket 2 will comprise of the nodes 1, 4 and 5, and bucket 3 will comprise of the nodes 5, 6, 8, 9, 3 and 7. So how do we write a code for this? So before writing the code, here I am going to tell you the structure of the code so that it will be easy for you. The code is a little bit involved, so it is important to understand its structure before writing the piece of code. Okay, so let's take this network, or we don't even need this network. Okay, so what we'll be doing is, let's say that here our code start. So this is the starting. What we are going to do is, we know that we have to recursively remove the nodes having degree 1 or less than 1 till there are no degree 1 nodes in the network. Next, we have to recursively remove the nodes having degree less than or equal to 2 from the network till there are no nodes having degree less than or equal to 2 in the network, so on and so forth. So in the beginning, I am going to take some variables. So I have a first of all, I take a list here and I name this list as buckets. What is this list buckets is? This list buckets is going to be a list of list. So it will be further consisting of many lists, and this will be the list corresponding to my bucket 1. This will be my list corresponding to bucket 2. Bucket 1 here means bucket corresponding to core 1, bucket corresponding to core 2 and bucket corresponding to core 3. So this is my array buckets, and the aim of our code is to fill this array buckets. And then I am going to take a variable, let's say it, which is initially 1. What this variable tells me? This variable tells me at a particular time in a code which degree nodes I am removing. So if the value of it is k, let us say, it means that I am removing the nodes having degree less than or equals to k. So that is my variable it. And then we have a array, or we have a list tmp. What this list tmp is going to hold is, so we are going to determine one of bucket at a time. So I might be filling this bucket at a particular time, I might be filling this bucket or this bucket. So t is going to temporarily hold this bucket. So initially the value of tmp is going to be initially, so tmp will start with empty, and then whatever values we'll put in tmp will be the values in b1. So we will fill tmp, we'll keep filling tmp, and a point will come where all the nodes having degree less than or equals to 1 will be removed from this network. At that time we are going to close tmp, and we are saying that we will go we'll say that this tmp is nothing but bucket 1, and we'll append tmp here. It will be further clear. Okay, so what we are going to do is, we have a start here. After start, we are going to check a condition. So initially we have it equals to 1 and tmp is nothing but empty. Okay, next what we are going to do, we are going to check a condition. And what is this condition? This condition is whether there are nodes of degree greater than, whether there are nodes of degree less than or equals to IT in this network, whether there are such nodes in the network, and the answer can be yes or no. So let's say here the answer is yes and here the answer is no. So if the answer is yes, what we are going to do? If the answer is yes, it means that still there are nodes of degree less than or equals to IT in this network. So we have to prune those nodes from the network. So what we will be doing is, find those nodes. So we find these nodes which have the degree less than or equals to IT, and what do? We remove these nodes from our network. So we remove these nodes from our network and we append these nodes in our array TMP, in our list TMP, which is the currently being filled bucket. So we append these nodes in TMP. That's what we do. And after doing this, we return back to here. So when the value of IT was 1, here what do? You find the nodes which have degree less than or equals to 1. You delete those nodes from the network and put them in your bucket. And after that you again see whether I'm very sorry. You come here. Okay. So after that, after removing these nodes having degree 1, you again see whether still there are nodes having degree less than or equal to 1 in your network. And again, if the answer is yes, you remove those nodes also and you keep doing this till there are no nodes having degree less than or equals to 1 in the network. So if the answer is no, what will you do? It says that your bucket is over. The bucket which you are currently filling is over. So what you do at this point, if the answer is no, you append your TMP to your bucket. So buckets.append TMP, that is your current bucket is full. So you do this, and what else you do? Now we have to start filling a new bucket. So we set back TMP to empty, and also we have removed all the nodes having degree IT. Now we have to start removing the nodes having degree IT plus 1. And after doing this, we go back to this place. So I hope the code structure is clear now. So this loop will keep running. So it will check for the value of IT equals to less than or equal, IT will be 1. So we check whether there are nodes of degree less than or equals to 1. We keep doing this. We keep coming back, keep removing nodes having degree less than or equals to 1 till there are no such nodes in the network. And when there are no such nodes in the network, we change IT to 2 and then we check the nodes having degree less than or equals to 2. We keep doing it. Now do you see? This code will keep running forever. There is some problem with this code. At one time, all the nodes from this network will be removed, and that is the time where we should stop. So what we are actually going to do is, before coming to this step and before checking whether there are such nodes in the network, we can actually put a small condition here. So before doing this, we can actually put a small condition there, and this condition will check whether my network is empty, whether my network has become empty, whether I have removed all the nodes from this network. And if I have removed all the nodes from this network, what I'll do, I'll simply append my temp to buckets. So see what is going to happen is, let us say that 5 is the maximum degree in this network and you are removing the nodes having degrees less than or equals to 5, and you remove these networks, and at a particular time when you remove a node, the network becomes empty, but your TMP will be holding the last nodes present. Last nodes which you have removed from this network are still present in TMP. So that bucket we still have to append. So at this time, we'll append temp to buckets, buckets.append temp, and you break. Now we will be implementing this, and I'm sure this will be further clear when you look at the code. You might want to keep this in front of you while writing the code, which will make your process easier. Okay, so next we are going to write the Next, we are going to see the code for Casial decomposition, and please note we need a little bit more complicated network. So for doing Casial decomposition and for all the further codes, we will be going to use this particular network, which is a slightly little bit complicated. So here if you look at the nodes present in nodes which will be removed in the bucket 1. So in bucket 1, these are the nodes which should be removed. So first you remove this node 2 and all these nodes 4, 8, 6, 7, 9 and 17 over here and 3 over here. And in the next iteration you will remove 1 and 5 as well, and then your bucket 1 will be over. And then in your bucket 2 you will be going to remove these nodes 11 over here and 12 over here. And then once you remove 11, you'll have to remove this node 10 over here also. So these nodes should be in your bucket 2. And finally your bucket 3 should comprise of these 4 nodes over here. So we will be using this network for our programming screencasts. So now we are going to write the code for Casial decomposition. So as usual, we import network X as annex, and we import matplotlib dot pyplot as plt. What we do next is we create a graph g equals to nx.graph, and we add some edges to this graph. So this graph which I am going to take is the same graph which we have seen previously in this video. So the graph which I am going to take is this. You can actually verify and see that it is the same graph. So we can also draw it and see nx.draw g, and then plt.show, and then we can execute and see it. So this is the network over here, and we have to look at various shells in this network. Okay. What we do next is, we have already discussed what we are going to do is, first of all, we are going to create a copy of this network h equals to g.copy, and whatever we are going to do, we are going to do it with h. And then we take our variable iteration corresponding to the degree, which is initially 1. And then we have a list tmp corresponding to the bucket which we are filling currently. So it is corresponding to the okay, let me write it down here. It is for the bucket being filled currently. Okay, and then we have a overall array buckets, which is nothing, which is going to be a list of lists, and each list here is a bucket. Okay, next what we are going to do is, we are going to run a while loop, while 1. So this loop will keep running till our terminating condition comes. And now we put a check condition, whether there are nodes of degree less than or equals to it in this network. So for that I use a function, and let us call this function as check existence. So flag equals to check existence, and what do I pass here? Our graph h and the degree. And let's define this function first here. Define check existence, where I have passed the network h and a particular degree. And how do I define it? It is very simple. So what do I do? Initially I set f equals to 0, which means that f is going to be 0 till the end of this function if in the case there is no node of degree less than or equals to d in the network, right? And then what we are going to do, for each and g dot nodes, we check each and every node in this network, and as soon as we find a node in this network whose degree is less than or equals to d, it means that still there is a node having degree less than or equals to d in the network. Immediately we set f to 1 and break this loop, right? And then we return f. So this f is going to be 0 till the end of this code if there is no node of degree less than equals to d, and it is 1 if there is even one node of degree less than or equals to d. Okay. So flag equals to check existence h comma it, and next what we have seen, flag can be 0 or 1. If flag is 0, it means that we have looked at all the nodes having degree less than or equals to it. Even recursively we have seen, we have pruned again and again, and there is no node of degree less than or equals to it. In that case, what we have to do, we have to mark our bucket as complete. So if flag is equals to 0, what do? We move on to the next degree. We set it equals to it plus 1, and we say that the current bucket is complete. So we append our temp to buckets, mark it as complete, and now we start with a fresh bucket. So this is nothing but start with a fresh bucket, right? Okay. And in another case, if flag was 1, what we are going to do? If flag is 1, it means that we have to keep pruning the nodes having degree less than or equals to it. In that case, first of all, we should find out such nodes. In the current network, we have to find the nodes which are having degree less than or equal to it. Let's call a function for that, and let's name this function as find. And so in the graph H, find the nodes having degree less than or equals to it, and we can quickly write a code for this function. Define find H comma it. And how do I define it? So initially this set is empty, and it is simple. For each in H dot nodes, if H dot degree of each, if H dot degree of each is less than or equals to it, what we are going to do is set 1 dot append each, and then return set 1, right? So we have found out all the nodes having degree less than or equals to it. Next we have to prune these nodes from the network and add them to our bucket. So what do? Prune these nodes from our network and add them to the bucket. So for each in node underscore set, what we are going to do is H dot remove node each. We have removed it from H, and we have to put it in our current bucket which is being filled, which is nothing but temp dot append each, right? In this case, we'll keep pruning the nodes, and the last part of the code is our terminating condition. So if while pruning these nodes, our network it becomes empty, what we have to do? So if network becomes empty is if H dot number of nodes, if it becomes equals to 0, what we have to do? We have to mark the current bucket as filled. So buckets dot append temp and then break. Okay. And now we want to see whether our buckets are correct or not. So for that, what we can do is we can simply print buckets. It tells us the different buckets in our network. So let's execute this code and see. An error at line number 27. Check underscore existence h comma it. Okay. F equals to 0 for each in g dot nodes. If I do deletion, what is the error? Okay, some error. Let's try to figure it out. Some very small error. So it, what is it here? It is a number, right? A particular degree. D. For each let's use some other variable here, d1. Okay, see a mistake here. Here we have used g dot nodes. So here we have to use h dot nodes, because if we are using g dot nodes here, we might here be talking about a node which is not there in h. H has less nodes than g. So it should be h dot nodes here. Okay. And let's execute it. Okay. So you see it here. Your one core is, the first bucket is from 1, 2, 3, 4. 6, 7, 8, 9, 17. Second is this, and third is this, and that is the result. So we have implemented K-shell decomposition. If you want, you can also color these nodes with different colors to see the different shells and so on.